Okay, welcome everyone to my channel, Erosion of Earth. I'm going to be looking at marine canyons in this video, and I'm going to track marine canyons very long distances. Okay, so here we can see that there's a marine canyon here. The width on it is over 2 miles at 4,200 meters deep. Okay, so that's really deep. So how do you get a canyon this wide, that deep, right? So that's a big question. In my previous video, I answered that on that. The answer is underwater debris flows, and I gave a lot of evidence to support that. So I suggest you guys check that out in order to see how these were actually formed. But I'm going to show you a few more canyons in this video and go over some other details with this. So here we're tracking this one, and it's over 1,000 miles. I also explained in my previous video how we get canyons to travel so many miles underwater. So if you haven't seen that, I suggest you check that out. Here we can just barely see a little section of it. We get clear data here to see that the canyon's still going. Looks like it's several miles wide, and we're just going to get an estimation for how long this guy is. And it's all blurry after this point here. Oh wait, no. Looks like the canyon continues right here. So we can kind of find its path. 1,600 miles. Oh, we get another section of path here. 1,700 miles. Looks like it goes through here. Looks like it comes through here. Right, still looks like it's several miles wide. Let's go, let's see how wide it is at 12, 14. It's about 3 miles wide there. So somehow we still get a 3 mile wide canyon after traveling 2,000 miles offshore. Okay, so that's quite the feature. Okay, so that was from kind of an exit of the Hudson Bay. We can see that these two intermediaries are streamlined, especially this one. And when we zoom in, let's see if we can see any cool features on it. Some accretion ridges and some drumlins here. You can see the drumlin paths. So drumlins don't have anything to do with ice. They have everything to do with sheet water flow. That's a major topic of my channel. So you can see that the drumlins here are facing in exactly the same direction. It's streamlined. And this one's streamlined even more clearly, as well as these two. Okay, but we're going to check out some other marine canyons we haven't seen yet. We got to check out this canyon here. Now, this canyon pops out not only because of its massive width. Let's check this width here. It's 2 miles at the base. And if we were to measure, from the top, it's over 5 miles wide. So it took a lot of force to remove all this rock and to bring it way down into the ocean basin. But what really stands out about this feature is you've got a perfectly symmetrical and very distinct feature here. This is a shallow cataract formation, and that's something I'm going to explain in greater detail in further videos. But basically, the idea with a cataract formation is water flows over this edge here, which is called the scarp edge, and it's able to carve a very distinct shape to it. So this is kind of it's pretty straight, but it's got a little curve to it, and it's symmetrical. So on this side here, you'd also have water flowing off of this, making this nice and flat. And then if you go over to this spot here, we see kind of a double cataract formation. If this intermediary lasted a little longer, it'd be more clear of a double cataract. And then this right here, these are, scarp edges, shallow cataracts that indicate an offshore current. And that offshore current has evidence of this massive canyon. I mean, this canyon is insane. If this was on dry ground, it would be insane to look at. So you got a nice marine terrace here. The Grand Canyon also happens to be terraced just like this. And you also have a massive canyon here. And let's get a width on it. Almost 1.5 miles. So that's quite the feature. 2 scarp edges here. But I want to show you guys another spot that I think reminds me of that. This is Puerto Vallarta in Mexico. And you've got the canyon that comes through. And then you've got the 2 scarp edges. It's got that nice straight scarp edge. Just kind of got that nice bend to it. Very straight, but still got the curve. And it's kind of divided in half as well. And it leads directly into this marine canyon here. It's not quite as large, but it's still very impressive nonetheless. Okay, now let's go to Japan. Here we also have the same feature. Straight scarp edge directly leads into a massive marine canyon. And these underwater scablands are very impressive. I mean, if you think about the sheer amount of energy it takes to remove all of this rock and to not just move it, but to break it off of solid rock, it's very impressive. Let's try to get a estimation. 5, 6. I mean, this is arguably more catastrophic than the Monterey Canyon, in my opinion. And if we got clearer data on here, I think that'd be very interesting, because it almost looks like it's really terraced, but you're not sure if that's just the default data or what. But if there was a bunch of terrace steps in this rock here, I mean, it looks like it's perfect terrain for it. You got nice curving, meandering water path, just like the Grand Canyon. And the Grand Canyon also has terrace steps, so this would be an underwater Grand Canyon. So yeah, this is a very amazing feature, and it travels a very long ways, hundreds of miles, until we get blurry data. So we're not actually sure. We know for a fact they travel over 1,000 miles, but in many, many cases we just can't track them all the way. Let's go to Australia next. Down under, we find ourselves a nice marine canyon. This guy is nice and wide. Also has marine terraces, right? So that's perfectly flat land. Terraced flat from ocean currents. And then from a different erosional force was this canyon carved. And from my other video, I talk about how the culprit of that was debris flows. Massive amounts of rock moving underwater. Wow, this one's 10 miles wide. So that's very impressive. but it doesn't go very far. We can't really track this one too far. We only see it go off the continental shelf and then it kind of disappears, but this is amazing. Okay, let's go to, what's it called? New Zealand. Now, New Zealand, you wouldn't expect it, but man, does New Zealand have some marine canyons. Sure does. Look at this. Just real impressive stuff. And this one goes for over 1,000 miles as well. It makes this corner, it comes around here, tucks around, keeps going. Not exactly sure where it ends. It definitely comes around here. Is this a piece of it? It's hard to say, but from, let's just say, okay, I guess it definitely comes through here. Let's just go from here. And we'll trace it backwards. Nice meandering water path. And then it kind of branches off. It reminds me of what we see in Washington, where you get several marine canyons converge to one long one. So it's 850 miles. And then, but the thing about this is, so you get a massive marine canyon that comes all the way around and wraps around. But the watershed is not very impressive. The watershed's like a third of this, if that, right? So it's a 150-mile wide piece of land. So there's not a direct correlation between watershed and marine canyon length. It has more to do with the types of rocks that are able to tumble off a mountain and ocean currents. And this has both of those features. It's got, it's right there in the ocean, and it's got a nice mountain range full of rocks. So that supplies us with the debris flow, supplies us with the ocean current. Okay, you get some nice marine canyons on this side, and New Zealand's divided right here, and you kind of get an expansion bar feature that reminds me of the English Channel right here. And then in the middle of this, as if this was carved out by the ocean current in a catastrophic way, you get a nice marine canyon. And if you were to count all the curves of this, it would be much longer than what I'm estimating it as. But yeah, it's over 700 miles. And this could even be, seems like this kind of over here looks like a marine canyon as well. It's hard to tell with this blurry imagery. Let's go to let's go to Africa. Okay, so Africa is one of the most textbook examples of sheet water flow. I mean, you don't even have to zoom in very much to see how, the ocean flowed off of this continent. It's quite obvious. I don't know why not many people are talking about it. Zoom in, then you find massive ripples, right? These are several miles in wavelength, about 2 miles in wavelength. Some of the bigger ones are. And then you've got these parallel features, which are a type of drumlin formation. You can see here these are drumlins, right? Also a feature of ocean currents, not glaciers. Now, why aren't there marine canyons coming right off of this? Well, it doesn't quite have the elevation change. So the mountains of New Zealand and the mountains of California, those have big elevation changes with lots of rock, high up with a lot of potential energy. This is all very flat. Africa is a flat continent. So you do get the same sheet water flow, you just don't have the inertia and the potential energy from going off of the continent. of a steep mountain range. Now you do get this nice marine canyon, but I mean it's so short. It's it's not very impressive compared to what we've seen. Only 100 miles. That's nothing, and that's just going off the continental shelf. It's not traveling across the flat ocean bed for hundreds of miles like we've seen in other places. Now let's check out the Congo River. The Congo River's got itself a little canyon, right? Very flat terrain, very flat, and it breaks through here, and you can kind of see this is like a U-shaped valley with a central river, and the width of this valley, 17 miles. We kind of see some mesas, some terraced lands, and then this canyon that comes right out as if this Congo River had a massive discharge. It actually looks pretty wide. Let's check the width on this guy here. 10 miles, yeah. So that's a very wide marine canyon. It just doesn't, we just can't trace it very far offshore. So it would be interesting to know how far offshore it goes. But so far we can't really tell. Let's go over to the India and Pakistan. So this river here, I'm forgetting the name of this river. Let's check. Indus, that's what it is. The Indus River, it's got a mega valley. It's got massive ripples, a mile in wavelength. It's got sediment lobes. It's got drumlins. See these drumlins? Okay, this is actually showing an inland current direction. But anyways, you also got scablands. Don't forget about those. And then you got the same thing, kind of like the Congo, where you also have this little marine canyon. Check the width, 7.6, very impressive. We just can't trace it very far offshore. And we also have kind of a more flat terrain. So we see a correlation between the areas with, they have mega rivers, they just don't quite have the very steep terrain that facilitates a powerful debris flow that just pushes and pushes the front of the debris flow forward. So that's kind of the limiting factor for these marine canyons. So I hope you guys found this video interesting. Hope you guys learned something. Give it a like, thumbs up, give it a comment if you got any questions. Look at this one here. It's very same thing. You can't really trace it a direct connection to the river, but you see the same short little marine canyon, kind of off a flatter terrain here. All right. So I hope you guys, I want you guys to share this with your friends because I'm trying to gain some following and I just need some exposure. I'd really appreciate it. Send this to your relatives, your family, friends. Thank you very much. And join me next time. There's a lot of features to study. I'm only scratching the surface. And if you want to get a heads up on all the stuff I'm studying, watch my documentary, Erosion of Earth, Part 1 and Part 2. I cover a lot of stuff. I just wasn't able to explain it in great detail, and that's why I'm going back in these videos to explain it in more detail so that you guys can get a clearer understanding of what these erosional features truly indicate. And the main point is that it is the ocean that eroded the Earth, and I can prove that with physics. All of these features can only form based upon catastrophic conditions of water. And water is something that when you study fluid dynamics, you can understand exactly how these features form. And yeah, that's basically it. And there's so many places on Earth that I can show you, like this spot in China. I can show you how these are drumlins sweeping across this landscape. And I'll give you the tools so that you'll be able to show your friends. Pull up Google Earth and then pull up some crazy stuff. Some sediment lobes, some drumlins, some salt scablands. And then you can go through and check out the current directions and all sorts of features. Right, drumlins here. So next time your teacher says, oh yeah, ice sheets make drumlins, say, okay, well, you know they're in Africa, Australia, Saudi Arabia, India, China. Got nothing to do with ice. And how also another feature I like to talk about is rivers through mountains, right? So when you get a canyon that goes directly through a mountain range, how did that form? Well, an ocean current washed back and forth until a canyon was formed. Okay, and then you've got all these sediment lobes to prove it, right? So how else would you get these fluvial sediment lobes pushed around up on these high mountains on the high banks of the river, right? I mean, when you really start studying it, it becomes quite obvious, and that's why I'm so confident in my theories. And then if you really want to check, you can count the marine terraces. You know for a fact the water level was here. Then you know for a fact the water level was here. This was once the bank of a river. Then you know for a fact this was the bank of the river. And then the modern river is just a little baby now, right? Not even a tenth of a mile. Only 63 feet. Only 63 feet today. And then we can go to the farthest out bank and see that that wasn't even it because we've got all these sediment lobes over here. All right, that's enough. You guys are starting to figure out too much. I gotta end the video.